In a previous video, we talked about transversal angles. Transversal angles are angles formed by a transversal, which is a line that intersects two distinct coplanar lines. In this figure, for example, line K is a transversal since it intersects coplanar lines L and M. If the lines that are intersected are not parallel, well, there's nothing special about this arrangement. But if the lines L and M are parallel, then we know certain things are true. And that's what we focused on in the last video. There are four, and actually there's a few more, but the four that we're going to focus on, four parallel lines theorem. So if two parallel lines cut by a transversal are parallel, that's true. So two parallel lines cut by a transversal are parallel if and only if corresponding angles are congruent. Two lines cut by a transversal are parallel if and only if alternate interior angles are congruent. The lines cut by a transversal are parallel if and only if alternate exterior angles are congruent. And the lines cut by a transversal are parallel if and only if consecutive interior angles are congruent. So those are four important parallel line theorems. Notice each of these is stated with an if and only if. And if and only if is important. If and only if means that if the lines cut by a transversal are parallel, so if I have parallel lines, for example, then I know that alternate exterior angles are congruent. But it also means that this goes in the other direction. If I know that alternate exterior angles are congruent, then I know that the lines are parallel. So in this video, what we're going to do is we're actually going to use these truths, these theorems, to talk about some situations, some problems. So, which of these lines? I've got some lines, and they are. There you go. Excuse me. I had to let my dog up on the bed. If these lines. Okay, I have lines L, M, and N. I've got lines P and Q. So here it's basically using the second part of the if and only if. If we know, for example, that angles 7 and 11 are congruent, what can we say about this figure? So if angles 7 and 11 are congruent. Okay, so both of those angles lie on transversal P. Neither of those angles has anything to do with M, so I think M is out of the picture in this. But angles 7 and 11 are corresponding angles. Along transversal P for L and N at lines L and N. Since these corresponding angles are congruent, we know that line L must be parallel to line N. Okay, so now each of these problems is independent, meaning that, okay, so if we knew 7 and 11 were congruent, then we can say that L and N are parallel. So now we have to forget the fact that so I'll say, well, what if I didn't know that? But what if I only knew that angles 8 and 9 are supplementary? So here's angle 8. Excuse me, let me get my pen going. Angle 8 and angle 9 are supplementary. Okay, those are interior angles for the lines L and M that lie along transversal P, and they're consecutive interior angles. If I knew that 8 and 9 were supplementary, then I know these are supplementary consecutive interior angles. If they are supplementary, then I know that line L must be parallel to line M. Lastly, how about angle 9 and angle 14? Again, if I know nothing else, if all I do is I tell you that angle 9 and angle 14 are congruent, then what can you say? Well, let's see. These angles do not lie on the same transversal. Okay, they're on different transversals. They're different vertices, different transversals. I don't think we can say anything. So let's see. So for line 9 and 14, let's suppose that that line, that's going to be angle 14 rather. Angle 14 is a right angle, so it looks like this. Or not even right angle, say it's a obtuse angle, so it looks like this. So there's angle 14. And say I also knew that angle 9 is 14, and that's all I knew. Well, couldn't my situation look like that? In other words, if it looked like this, and this is 14 and that's 9, then it doesn't look like I have any parallel lines. So if all you know in this figure is that angle 9 and 14 are congruent, can you say anything? Turns out you cannot. So from C, there is no conclusion. So let's finish up with a couple problems where we are given a situation, a transversal that basically crosses line, transversal T, intersects lines L and M. And what do we need to know about angles 6 and 2 for L and M to be parallel? So here's angle 2 and here's angle 6. Those are corresponding angles. If those corresponding angles are congruent, then I would know that L and M must be parallel. Congruence, so if angle 2 is congruent to angle 6, then I know that L is parallel to M. All right, congruent angles means their measures are the same. So that means that the measure of angle 2 must equal the measure of angle 6. So I could set up the equation. Measure of angle 2 is x times x minus 1. And I'll set that equal to x squared minus 9. Let's distribute my x. So x squared minus x equals x squared minus 9. Subtract x squared from both sides, which leaves negative x equals negative 9. Then if I multiply both sides by negative 1, I get x equals 9. So if x equals 9, let's see, what does that mean? If x equals 9, then the measure of angle 6 would equal 9 squared, which is 81 minus 9, which is 72. If x equals 9, then the measure of angle 2 is going to be 9 times 9 minus 1, which is 8, which is also 72. So each of these would be 72 degrees. These are corresponding angles which are congruent. That would force lines L and M to be parallel. The final problem like this is, what do I need to know about lines 3, or angles, 3 and 5? What would I need to know about angles 3 and 5 in order for lines L and M to be parallel? Well, 3 and 5 are consecutive interior angles. Consecutive interior angles, if they are supplementary, then lines L and M would be parallel. So if 3 and 5 must be supplementary, I know that the measure of angle 3 plus the measure of angle 5 would equal 180 degrees. So let's set up that equation. We've got a fair amount of algebra to do in this one. Measure of angle 3 is x plus 1 times x plus 4. And that the measure of angle 5, which is 16 times x plus 3 minus x squared minus 2, and that has to equal 180 degrees. Okay, let's FOIL or distribute the x plus 1. So I've got, this is going to be x squared plus 1x plus 4x, outer times outer, plus 1 times 4 is 4. Distribute the 16, plus 16x. 16 times 3 is 48. And then distribute my minus x squared, so distributing, minus a negative 2 is plus 2, equals 180 degrees. Let's collect our like terms. So I've got 1x squared, take away 1x squared, so those will cancel. I've got x plus 4x plus 16x, so 21x's, plus 4 plus 48 is 52, plus another 2 is 54, so plus 54 equals 180. Subtract 54 from each side, and I get 21x equals 126. And when you divide each side by 21, you get x equals 6. So let's check. If x equals 6, measure of angle 3 would be 6 plus 1, which is 7. 6 plus 4, which is 10. So measure of angle 3 would be 70. Okay. Measure of angle 5 would be 16 times x plus 3 would be 9. So 16 times 9, which is 144. So I'd have, I'll move over here, 144 minus 6 squared is 36. So 36 times, or minus 2. So 36 minus 2 is equal to, what is that, 34? 36 minus 2 is 34. So 144 minus 34 equals 110. So if x equals 6, then the measure of angle 3 equals 70. The measure of angle 5 equals 110 degrees. Those are supplementary. Supplementary consecutive interior angles. That means that L and M must be parallel.